You cannot see it, you cannot feel it, but it is the only reason you are alive. 2,000 kilometers beneath your feet, molten iron churns in the dark, spinning and shifting, generating an invisible force field that wraps around this entire planet. We call it the magnetosphere. We take it for granted. We should not. Because if it vanished tomorrow, Earth would not simply lose a shield. It would begin to die. Let's start with what this field actually does. Right now, every second, without you ever noticing. The sun is not calm. It is a constant, violent storm of charged particles, streaming outward in every direction at nearly 1,000,000 miles per hour. This is called the solar wind, and it never stops. It has been blasting toward Earth for 4.5 billion years. Without our magnetic field, this radiation would strike the surface directly. Instead, it hits an invisible wall first. Earth's magnetic field deflects the vast majority of this deadly radiation around the planet entirely, forcing it to flow past us like a river splitting around a boulder. What little does get through is funneled harmlessly toward the poles, where it collides with our atmosphere and creates something beautiful, the aurora. That shimmering green and violet glow in the night sky is not decoration. It is the visible signature of our planet's shield, absorbing an attack we never even feel. Now imagine that shield simply switching off. At first, almost nothing would look different. The magnetic field would not vanish instantly. It would weaken gradually, over centuries, as the internal dynamo powering it slows down. But the consequences would begin long before the field reached zero. The first casualties would be technological. Satellites orbiting above the atmosphere currently rely on the magnetosphere to deflect the worst of the solar radiation. Without it, satellites would face constant, unfiltered bombardment from charged particles, frying electronics, corrupting systems, and dramatically shortening the lifespan of every satellite in orbit. GPS, communications, weather forecasting, banking systems that rely on precise timing signals from space, all of it degraded or destroyed, and it would not stop in orbit. A weakened magnetic field means our upper atmosphere becomes directly exposed to solar storms, and when the sun releases a major coronal mass ejection, a massive eruption of charged plasma, that energy would surge directly into Earth's power grids. In 1989, a solar storm far weaker than what an unshielded Earth would experience knocked out the entire power grid of Quebec in under 2 minutes. Now imagine that same event, but without a magnetic field to deflect and weaken the impact first. High-voltage transformers could overheat and fail as powerful geomagnetically induced currents surged through transmission lines. Large sections of power grids across multiple countries could collapse simultaneously. And unlike an ordinary blackout, recovery could take months or even years, because the massive transformers needed to rebuild the grid are highly specialized, custom-built machines that cannot simply be pulled from a warehouse. Modern civilization runs on electricity. Remove the shield protecting our grid, and you do not just lose your lights. You lose refrigeration. You lose hospitals. You lose water treatment. You lose the invisible infrastructure holding 8 billion lives together. But this is only the beginning of the danger, because the true cost of losing our magnetic field is not measured in decades. It is measured in geological time.
Look at Mars. Billions of years ago, Mars had its own magnetic field, its own protective shield. And by many estimates, Mars once had oceans, rivers, and a thick atmosphere not unlike early Earth. Then its core cooled, its magnetic field collapsed. And without that shield, the solar wind did something we rarely think about. It did not just increase radiation at the surface. It began stripping the atmosphere away. Charged solar particles, no longer deflected, slammed directly into the outer edges of the Martian atmosphere, knocking molecules loose and carrying them off into space, one violent collision at a time. Over hundreds of millions of years, this slow erosion stripped away most of the atmosphere that once protected Mars. What remains today is a thin, frozen, radiation-blasted desert, a dead world that was once alive.
This is what an unshielded planet actually becomes. Not overnight, not even within a human lifetime, but inevitably, given enough time. If Earth's magnetic field disappeared tomorrow, this same process would begin here. Our atmosphere is thicker than Mars's ever was, and the erosion would take far longer, likely hundreds of millions to billions of years, to strip away significant portions of it. This is not a tomorrow apocalypse, but it is a slow-motion one. And there is a more immediate danger hiding within that timeline. Without a magnetic field, our atmosphere loses its protection from cosmic radiation as well. Not just solar particles, but high-energy radiation from deep space.
Cancer rates would climb, DNA damage would increase across the entire biosphere, not just in humans, but in every exposed organism on the surface. Migratory animals that navigate using Earth's magnetic field, birds, sea turtles, whales, would lose their internal compass entirely, wandering lost across oceans and continents they once crossed with perfect precision. The web of life that evolved for 4 billion years beneath this invisible shield would be forced to adapt to a world it was never designed to survive in.
Here is the unsettling truth beneath all of this. Earth's magnetic field has already flipped entirely, reversing its north and south poles at least several hundred times throughout our planet's history. During these transitions, the field does not vanish, but it can weaken dramatically for centuries at a time, sometimes dropping to a fraction of its normal strength. We are, according to some measurements, currently inside one of the weakest points in our magnetic field's recent history, with certain regions already showing measurable decline. We do not know exactly when the next full reversal will happen. We only know that it has happened before, many times, and it will happen again. The shield above your head, the one you have never seen, never felt, and rarely think about,
is the only reason there is a sky worth looking up at all.